everybody, this will be a recording for 2.21 alternate assessment. I know a bunch of you are not able to play the simulation, so I'm going to go ahead and demonstrate that. I'm going to go ahead and run this Java program. Hopefully it will come up in just a moment. And basically I will demonstrate what needs to be done as far as collecting data goes, and then from there you can go over to the template to complete that. So we're going to start with the part 1, which is constant velocity. And here what we want to do is choose a constant velocity. So I'm just going to choose 2 meters per second. And then we will play a little simulation to see what the graphs turn out to be. And I'll stop him right there before he hits the wall. So you can see we have some data here, a time of motion, his position, velocity, and acceleration. You can record the graphs for question number 1. And then question number 2 asks you to take some data from these graphs and come up with a story problem. Design that story problem so that it includes both velocity and distance. And then move on to question 3, where you'll actually do some calculation. Ideally, when you get to 3B, your calculation should agree with what you see here in the simulation. If those numbers don't match, that may be an indication that you need to go back and make some corrections. All right, so that was part 1. And like I said earlier, if you need to pause this to mark down your graphs on the template, you can go ahead and do that. When you are ready, go ahead and press play again, and we'll move on to part 2. Okay, so for part 2, I'm going to reset this. And we're going to adjust it so that we have a starting velocity, or initial velocity as we call it, of 1. And I'm going to choose an acceleration of 2. Oh, let's make it 2.5 meters per second squared. Now we should see the graphs a little bit differently in the fact that the person is moving at a constant acceleration instead of a constant velocity. So I'm going to go ahead and press play here, and I'll let him make it to the wall there so we can kind of drop off the part where he crashed into the wall. We only want to look up to the point where he gets to the wall. And now we can see the graphs are a little bit different. So if I zoom into, I'm going to minimize and zoom into our position versus time graph first. You can see there what actually happens is there's more of a curve because of the acceleration. You want to make sure you record that in question number 1 of part 2. Now if we look at velocity, we don't want to pay any attention to that vertical line. That's where he hit the wall. But up to the point at the end of the graph here, we can see that it is a slope, straight slope, and the initial y-intercept is not at 0. So you want to make sure you record that properly. And then the last one is acceleration. And this one I'm going to zoom into a little bit. Oops. So that you can see it maybe a little more clearly. And of course, we're just focusing on this horizontal segment. Notice that it is a constant value, and it's really that value that we selected earlier. We don't have to record the vertical lines, so we're stopping right there. All right, so I'm going to bring all 3 of these back so you can look at them again if you need to. And what you want to do for question 2 of part 2, again, is to write a little bit of a story problem, giving an example of constant acceleration, include initial velocity, which I mentioned earlier, acceleration, and the distance covered. Using those, you'll be able to do some calculations and again confirm that the simulation agrees with your calculations. So that's it for the recording. I hope this helps you move forward with 2.21. And if you have any remaining questions, please reach out to me.